Hmm. Yeah, Haripriya is here. Anishka is here. Radhika is joining. Oh, wait, wait, wait. Haripriya, how is my voice? It's okay, na?
Yes, sir.
Yeah, your voice is becoming somewhat loud. What we were studying in the last class. Hmm. Let's start. What is the problem with Radhika? Radhika is saying she is not able to join. Let's say again. See, in the last class, what I've told, they will be joining. Shiva and that. Acha. See, in the last class, I've told you moment of inertia of a uniform for a thin rod uniform mass distribution. We using this one. Similarly, let me tell you about the circular ring also and then disc also, this slab also. Okay, we'll do it. Then you will understand it how we are doing it. Haripriya, tell me one thing. You join using from laptop or from this one phone?
Sir, I join in both sometimes. Like yesterday and day before yesterday, I joined in mobile. Today I'm in laptop.
Today, laptop na. Hmm.
Yes.
Why I'm asking na, because this Radhika was saying he's facing some problem. I don't know what is the problem. Still she's saying load हो रहा है. So what is the problem? But I think if you guys are not having problem in joining, the problem is with her laptop only. You should rectify it. See, Deva has also joined. Shama has gone out for some function, so he is not able to join. He'll be joining later. See, this is for the ring. How to find the moment of inertia? This is very easy. For a ring, finding out moment of inertia is actually very easy. How? Because this is radius r. देखो, in this what will happen? See, in this, if we want to find the moment of inertia, if we take an element also at some distance, suppose I have taken this element, let it be its mass is dm. This mass is also, if we say, if we take every mass from this particular axis, every mass from this particular axis at the same distance, right? So it is at the same distance, then there is no point in integrating actually. If we find out di, it is r square into dm. So if we try to find total moment of inertia, it will be integral r square into dm. And since r is constant for each mass, this r square will come outside, integral dm. So I is equal to r square into integration of total, this dm is total mass. So it is m into r square. That's why it's very easy. Finding out the moment of inertia of a ring, it is mr square. Easy?
Yes, sir.
Hmm. Now let's find out, let's check the result also. The moment of inertia for a circular ring is mr square. About this, rest all things you can find out using the parallel axis theorem and perpendicular axis theorem. Now let me show you how to find moment of inertia for a disk. So can anyone suggest me how can I proceed in this? Because since you must have got the idea how to use the integration and how to use this one, and since in the case of center of mass also we have tried the similar thing. Can anyone tell me anything about this?
So we will break the disk into rings.
Good. We'll break the disk into rings and then we'll try to find out the total moment of inertia. Integral. Now, since you have told me the way, now can you proceed by yourself? Try to do it by yourself. Is it is it easy or difficult for you? Take the total mass of the disk is m is the mass of disk, and r is
So
its total
what
radius.
would DM be
What
for
will
this? DM be for this?
dm? I don't understand what you are saying. What dm?
Yes, sir.
dm?
The
You have to find it out. See, if you take the ring, see, let me show you. If you take a ring of this kind, let me draw the ring first. This is the ring. This is the ring. If you take its radius as small r and its thickness as dr, the mass of this whole disk is capital M. So mass per unit area will find, which is m by pi r square. Now for this particular ring that I have shown, this particular ring, the area will be, we can write its area as 2 pi r into dr. Its mass dm will be sigma into its area, which is sigma into 2 pi r into dr. That's your answer. Now the total moment of inertia for the formula is integration di. I is equal to integration di, which is r square dm. For this, you have to integrate r from 0 to capital R. Now try to, everything I have given, try to integrate it and try to find out the total result.
mr square by 2.
Mr square by 2, correct. See, you got the result. If I will get cancelled, 2m by r square, r cube dr, 0 to capital R. The result is 2m by r square, r power 4 by 4. So 2 to the 4, this cancelled. Mr square by 2 is the result. This is your answer. See, now coming to the next part, let's try for the rectangular slab. The similar result will be for square slab. So this would be your last, finding out the moment of inertia. Moment of inertia for rectangular slab. Can anyone suggest me how to find the moment of inertia for rectangular slab?
Rectangular slab is just a
It's just a
cuboid.
cuboid.
Can we break it into rods?
Yes, that can be done. Oh, what is happening with Radhika? Radhika is trying to join from the initial. She's trying to join and then she's not able to join. Do you guys do anything else? Tell me, Diva, Haripriya, Kanishka. देखो राधिका अब ज्वाइन कर लिया. राधिका पहले तो तुम मुझे ये बताओ कि तुम्हारे साथ प्रॉब्लम क्या चल रही है और अब कैसे ज्वाइन हुआ है.
अरे मेरे पापा के लैपटॉप से.
तो तुम्हारे जो बाकी जो डिवाइसेस हैं उनसे तुमने अनइंस्टॉल करके देखा उसको?
सब ट्राई कर लिया, लैपटॉप से भी ट्राई कर लिया था एंड मैंने अपने फोन से भी ट्राई कर लिया, आईपैड से तक.
फेंक दो अब दोनों को।
करने का प्लान है अब।
क्या
पता
है?
नहीं क्या हुआ, मैंने केमिस्ट्री वाली वो रिकॉर्डिंग में देख ली।
हाँ, तुम्हारा एप्पल डिवाइस है क्या, कौन सा डिवाइस है?
आईपैड है एप्पल का और बाकी दोनों एंड्रॉइड है।
आईपैड तो पता नहीं।
तो बहुत पहले से पड़ा हुआ था, मैंने सोचा उसको भी ट्राई कर लेता हूँ। हर चीज को तो कर ही चुकी हूँ।
पता नहीं, तुम्हें रिस्टॉल करना पड़ेगा,
वो
क्योंकि
भी कर लिया ना।
कुछ भी नहीं करना पड़ता है। जस्ट यू हैव टू जस्ट क्लिक इट एंड देन यू विल गेट एंटर।
वही हो रहा था, आज तक मेरे लैपटॉप पे सही चल रहा था, पता नहीं लास्ट के 1-2 दिन से पता नहीं क्या प्रॉब्लम आ रही है। या तो लैपटॉप पे प्रॉब्लम हो, क्योंकि जूम या जूम में भी हो सकती है, क्योंकि हर डिवाइस पे प्रॉब्लम आ
एक
रही है
देखो,
ना।
सी, if you get this kind of problem, I did not tell you something, this one, especially राधिका। अगर देखो राधिका तुम्हें प्रॉब्लम आ रही है तो पता है एक और चीज ट्राई कर सकते हो, अगर ऐसी चीज आती है, वैसे बहुत रेयरली आता है जूम में, अगर ऐसा आया तो राइट क्लिक करके ना, सी दिस वन, राइट क्लिक on your Zoom and try to run as administrator. Run it as administrator, then there won't be any problem. This is the solution for everything, because administrator means you are you are administrator.
ओके, सर अभी तक आपने क्या करवाया है?
कुछ नहीं, मैंने अभी अभी तक बस मोमेंट ऑफ इनर्शिया बताया है, मोमेंट ऑफ इनर्शिया फॉर ए रिंग एंड मोमेंट ऑफ इनर्शिया फॉर ए डिस्क, हाउ टू कैलकुलेट यूजिंग इंटीग्रेशन।
ओके, तो डायरेक्ट इसमें याद करना, फिर लाइक फाइनल रिजल्ट को देखना है या फिर डेरिवेशन भी?
डेरिवेशन देख लो।
ठीक है।
Why? क्योंकि why I'm see, this derivation is according to most of the teachers, this is not important and they do not focus on this also, but I focus. Why? Because in the advanced questions and this JEE main type of question, sometimes when they set the paper tough, what they do, they change the mass densities, mass density of this, mass density of that. In that case you should know this process, otherwise you won't be able to solve.
ओके,
अच्छा, नाउ विल मूव ऑन टू द नेक्स्ट पार्ट। बाकी के उससे देख लेना, वो उससे देख लेना, जो मैंने रिकॉर्डिंग दी हुआ है, रिकॉर्डिंग में से देख लेना। अच्छा, फॉर दिस रेक्टेंगुलर स्लैब फाइंडिंग आउट द मोमेंट ऑफ इनर्शिया, actually Diva has told me very good this one. No, Haripriya, not like you cannot do it like this one cuboid, because cuboid is 3-dimensional na.
Yes.
Why why unnecessarily complicating things? When 3D things are not there in your syllabus, why unnecessarily complicate things? Cube is also not there, so don't worry about that. Rectangular slab is there. Diva told us a very good this one, very good idea. He gave a very good idea that can be applicable. What you can do is, this side is A, this side is B. About 3 we'll find out. This side is A, this side is B, and about the middle one we have to find out. Acha, Diva or anyone, what Diva said that we will be finding out the moment of inertia using taking the rods. Okay, now we can take the rods, but how? Diva, can you tell me? Or Haripriya, can you tell me? Or Kanishka or Radhika, anyone? The rods will be of which type? Means it will be horizontal or vertical? How you want to take? That way only I'll take it.
Now, will it make any difference? Or the final result will be same, right?
Yes. But I wanted to ask you, I wanted to give you a choice how you want to take that, then only that way only I'll do the integration.
It can be kind of vertical because horizontal we've done in center of mass, I think. So vertical we haven't
Okay,
done.
okay, we'll do vertical then. See, in this vertical case, we'll take a rod like this. Rod is obviously of length B and is the, let's take its breadth as dx. Okay, and let's say it is at a distance of x from the center. Okay, now the first task is, this is the rectangular slab. Now if I wanted to wanted to calculate mass per unit area, how it will be? Mass per unit area, sigma will be what? Its total mass divided by area A into B, correct? Now what will be the mass dm? Can anyone tell me what will be the mass dm of this rod that we have taken? Repeat, tell me.
Sigma into
Or anyone else, whoever knows. Sigma into its area, na? The rod area. Because you have found out mass per unit area. For 1 unit area, you have found out the mass as m by ab. Now for finding out its mass, what it will be? Mass per unit area into the area of this rod, which will be sigma. Sigma is the mass per unit area, into its area is b into dx. That's all. That's
dm.
So dm will be equal to m by ab into b dx. Then you can cancel this. Oh, sorry. Then you can cancel this b with b. So the dm mass of this has become m by a into dx. Found out mass. Now the task is we are doing moment of inertia we are taking the moment of inertia of the rod about an axis of this rod about an axis passing through its center perpendicular to it. Does anyone remember that result? I don't expect you to remember now because it's just day for yesterday only I have taught you. The result is ml square by 12. This one. Moment of inertia of the rod about an axis passing through its center perpendicular to it is ml square by 12. Right? Okay. Now the moment of inertia of this rod about this one is about an axis passing through this center. This one, where see where my cursor is. About this this axis is dm into di is dm into dig is dm into b square by 12. It's center, but we have to find out the center of mass about this third point, this point, center point. So we'll apply parallel axis theorem. So I about 3, di about 3 will be equal to dig plus dm into x square. So it will be dm into b square by 12 plus dm into x square. Is it okay for everyone?
Yes, sir.
Now what I have done, I have found out the moment of inertia of this rod about the axis passing through the center of this planar, this rectangular slab. Now I will integrate it. Let me put the value of dm. So di3 will be equal to b square by 12 plus x square into dm is m by a into dx. Now let's integrate it. Can anyone tell me what will be my integration limits? I will be equal to integral di3, and here when I will integrate m by a into b square by 12 plus x square into dx, what will be my limits?
0 to a.
No, see, you have to remember from where I am taking x. I am taking x from the center. So x, my origin is at 3, this point. So if I move from this origin to the left side, it will be minus a by 2, na? And from origin to the right side, it will be plus a by 2. You have to be very particular about from where you are taking the distance. If I would have taken this rod and its distance from one corner as x, then your then your limits 0 to a was correct. See what I'm saying, na? If I would have taken a rod like this kind of rod, and I have taken its distance x from one end, then 0 to, then I can take x as 0 to a, because I have taken my origin from this side, any of this one side. Now my x will change from 0 to the rightmost corner, but now I am taking x from the center, so x will move from minus a by 2 to plus a by 2. Understood? You are okay?
Yes.
What about others? Haripriya, Kanishka, Radhika. Okay for everyone?
Yes, sir.
Okay. Now see, it will be from minus a by 2 to plus a by 2. Now just integrate it. I will be equal to m by a will come outside. And minus a by 2 to a by 2. B square by 12 plus x square dx. Now keep m by a. I actually getting doubt whether I will get the right answer or not. Square by 12 into minus a by 2 to plus a by 2 dx plus minus a by 2 to plus a by 2 x square dx. Method is correct. B square by 12 into a by 2 plus a by 2 is a, plus x cube by 3, x cube by 3 minus a by 2 plus a by 2 m by a, b square by 12 into a plus a cube by 8 plus a cube by 8 1 by 3. It will be m b square by 12 plus m by a into a cube by 12. We've got the answer. M by 12 into a square plus p square. See, this is the moment of inertia, final moment of inertia about the center. Okay. See, it is according to what you asked. I was thinking something else. I was thinking of taking the rod as horizontal. Is it complicated? Tell me. Okay. Everyone okay? See, just observe it. Okay. Now, see, for the square, what you will do for square, it's actually easy. For if they want you to find out the moment of inertia about this axis 4, it will be just a, the both sides are same, a and a. In the result, if you put m into m by 12 into a square plus b square. Here you have to break a and b as a equal. So 2m a square by 12. So the answer will be m a square by 6. That's all. Now, interesting is this. I1 is okay. I1 is m a square by 12. I3 is also m a square by 12. Because obviously that perpendicular axis theorem you can use now. Here also in the rectangular slab also you can use the perpendicular axis theorem. But but see, in the case of square you can use the perpendicular axis theorem. Okay, this will work because about axis 1 and about axis 3, this square slab is this square slab is actually what? Symmetric, like we used to do. But here in the rectangular slab you cannot. That's why you are getting different result. Otherwise, if you were taking I1 is equal to I2, in that case you would have got m a square by 24 like that. M a square plus m into a square plus b square by 24. But here I1 cannot be equal to I2 because if you take about I1, body is different. If you take about I2, body is different. So perpendicular axis will work. I1 plus I2 will be equal to I3. But you cannot make I1 is equal to I2 here. But in this case, you can make I1 is equal to I2. Okay. Understood, everyone? For this solid sphere, just remember these results. No need to do the integration. I won't tell you also because that's too complicated for you right now. You'll become confused. Now let me give you some questions regarding the moment of inertia. Because this part is very important. Moment of inertia. So in this, one more result is missing. Cylinder. For a cylinder, they have not given. For a cylinder, the moment of inertia is mr square by 2. Let me draw that also. If this kind of cylinder is there, no? And it's, see, remember it's the solid one, not the hollow cylinder. For a solid cylinder, it is mr square by 2. And rest all the result I have given. For solid cylinder is this, and for hollow cylinder, it's mr square. These two also, if you remember, are good.
So
Okay, now
what will be the derivation for the hollow cylinder?
cylinder. What is for derivation? It's take any mass C, any mass at at this end. Okay. each mass is at a distance of r from this axis. So if you take all the masses, see, each mass is at a distance of r. For each mass, it will be dm into r square, di. And the total moment of inertia will be r square will come outside integral dm. So it will be m into r square, na? Because every mass, whatever mass you take for the hollow cylinder, every mass is at a distance of r only from this axis. Getting it? समझ में आया राधिका? अरे, it's like a ring. See, in a hollow cylinder, if this hollow cylinder is there, wait, if this hollow cylinder is there, take any mass. For integration, what we do? We take any elemental mass. Any elemental mass on its surface can be taken like this. Suppose this is dm. This dm is also at a distance r, na? Any mass you take on the surface, every mass will be at a distance r only. Try to visualize the cylinder first. Any mass dm that you take, it will be at a distance of r only from the center, from the central axis. So the moment of inertia di for this dm mass is actually r square into dm. The total moment of inertia di will be equal to r square integral dm, because r is constant for everything, every mass. So it will be r square into m. That's why the total moment of inertia is m into r square. अब समझ आया?
Yes, sir.
Very easy. Acha, try to do this question. Attempt it. First try to understand it and then see whether you're able to solve it or not.
So can you scroll up a bit? In a circular disc.
डिस्क का ये है ना एम आर स्क्वायर बाई 2.
Okay. So can you show the question दिखा दो. तो 17 है क्या वैल्यू?
17.
Yes, everyone, I got 7.
17 only. Answer is 71. Everyone is getting now? So no need to solve? Yes. Haripriya has got the answer. Haripriya has got the answer. Kanishka, you got the answer? Diva?
So I'm still solving.
Still solving. Acha. Let me select one more question. If you are able to solve by then, okay, otherwise I'll solve. आया नहीं ये क्वेश्चन. This is new.
Sure, I got it.
Got it? Kanishka आया? So you guys try to solve this question. Let me solve it.
Scroll it down a bit.
ठीक है. ICM is a moment of inertia of circular disc about an axis passing through its center and perpendicular to node. IAB. It's easy only. Disk is
मोमेंट ऑफ इनर्शिया ऑफ दिस तो वही होगा ना मास पैदा तो
हाँ
नीचे वाले बट यहाँ पे टैंजेंट है चेंज
हाँ
क्या होगा फिर
तो परपेंडिकुलर एक्सिस थ्योरम लगाना पड़ेगा ना, पर तुमने वो पढ़ा नहीं है ना। वीडियो देखा पिछले वाला? नहीं देखा? अगर तुमने देखा होगा तो तुम कर लोगे। पकड़ में आ गए भाई साहब, पकड़ लिया।
क्या होता है परपेंडिकुलर
नहीं पता? आई एक्स प्लस आई वाई इज इक्वल टू आई जेड। तुमने तो बोला था सर मैं देख लिया वीडियो।
मैंने उसका देखे केमिस्ट्री
केमिस्ट्री का देखा है? अच्छा अभी बताता हूँ, रुको। 17 mr square by 18 divided by mr square by 2. So this will get cancelled. So it will be 17 by 18 into 2. So it will be 17 by 9. That's why the answer is 17. देखो परपेंडिकुलर एक्सिस थ्योरम क्या होता है ना, अगर कोई भी बॉडी है ऐसी, इसमें दो एक्सिस हैं, ये एक्सिस x है, ये एक्सिस y है, तो अबाउट मोमेंट ऑफ इनर्शिया अबाउट एन एक्सिस z जो कि परपेंडिकुलर तुम्हारी तरफ आ रही है, ix प्लस iy इज इक्वल टू iz। अब इसमें जो ix और iy है ना, ये बॉडी के प्लेन में होना चाहिए, ठीक है राधिका? ix और iy प्लेन, बॉडी के प्लेन में होना चाहिए। अब इसमें भी एक चीज होती है, अगर बॉडी सिमेट्रिक है, जैसे सर्कुलर बॉडी है, in this body is symmetric. If you take y or x, they are exactly same. About y-axis is the body symmetric, about x-axis also the body is symmetric. So in that case, you can take ix is equal to iy. So it becomes very easy to find out the moment of inertia in that particular case, because iz you already know it's mr square by 2, and ix is equal to iy. So you can do it 2ix is equal to mr square by 2. That way you can find out ix or iy which is equal to mr square by 4. This is actually the moment. This is actually the perpendicular axis theorem.
So 5/7 x की वैल्यू 5 है क्या? नहीं, हाँ 5 होगी।
x की वैल्यू 5 है,
हाँ 5/7 आ गई।
देखने दो फिर।
जब मैं डिस्क और टेंजेंट का निकालती थी तो 5r² है, और स्फेयर और टेंजेंट का करती 7r² आ गया।
करेक्ट,
रेशियो आ गया उसका 5/7।
x is 5. What about others? Everyone is getting the answer?
Yes.
Okay, very good. So the answer is 5 for this, so no need to solve. I'll give you a few more questions. I'll give one interesting question here. See, the moment of inertia in 2023, they gave one question. It's not that difficult, but it's somewhat tricky. You may do some mistake in this, I think. I may be wrong also. This is the question. Take this. Try solving this. Acha, how you are finding these questions? They're easy, na? See, they're asked into JEE main examination, but still they're easy. Very easy because you are able to solve them easily, right? Why? Because nowadays the JEE main questions, JEE main are actually asking easy questions. To score good in your JEE main examination, you have to just properly complete the syllabus, not just reading the theory. Solving some basic level questions, you will easily score in JEE main. Nowadays, they're asking JEE main mathematics paper is difficult. It's not difficult, it's a bit lengthy.
Is the question incomplete?
Question incomplete?
The last line, they've given a blank, but they've asked the value.
Diameter will be in the ratio of. Acha. Wait. What they meant, it should be diameter is in the ratio of x by 6. You have to find the value of x then. See, from the next class in this rotation, the interesting part will start. The conservation of angular momentum, torque, the basic torque theory, you know. So I won't, I will revise it once again. Basic torque theory, then basic torque, and then conservation of angular momentum, conservation of linear momentum, you know. And then will come the interesting part, rolling with slipping, rolling without slipping, where both the translation and rotation motions are involved. Like if you see in your cycle, motorcycle or car that uh, wheel rolls na also moves forward, motion that motion. It's the most confusing part for student where they find difficulty.
So
Yeah. Hmm.
ये पहले मैंने वॉल्यूम ऑफ दिस पाया स्क्वायर आरटी करके करा है, फिर m is equals to like density into वॉल्यूम कर दिया है, फिर दोनों को इक्वल कर दिया है और वैल्यूज पुट कर दिया है. तो अब मेरा क्या कहते हैं इससे, डेंसिटी के उसको क्या कहते हैं सिंबल को जो बंदा
रो।
सोचता है, रो, रो
हम्म,
वन अपॉन रो टू
फिर
आ
से
रहा है।
बताना क्या किया है।
वैसे मेरे फाइनल में रो वन अपॉन रो टू आ रहा है, अब उसके आगे कैसे करूँ?
रो वन अपॉन रो टू आ रहा है।
मतलब मैंने रेशियो निकाल दिया उसका रो वन अपॉन रो टू का, मतलब वो तो निकला हुआ है, सॉरी।
और
मैंने
क्या।
आर आर वन अपॉन आर टू का निकाल दिया, स्क्वायर दोनों का।
हाँ तो ठीक है ना, थिकनेस भी तो दिया हुआ है। तुम्हारा
हाँ
जो रेशियो ऑफ द रेडियस है ना, वो डेंसिटी और थिकनेस के टर्म्स में आएगा।
हाँ, उसके टर्म्स में आ रहा है, वन अपॉन टू रो टू अपॉन रो वन आ रहा है, बट वो तो मैं उसको रेसिप्रोकल कर दूं ना, जो हमें ये दिया हुआ है, इसको 5/3 मान लो।
हाँ, डेंसिटी रो वन बाई रोटी, एक पहले
हाँ
की
तो
डेंसिटी
ठीक है
3
ना,
है, दूसरे की
तो
5 है।
हाँ तो 5/6 आ रहा है, एक्स
हाँ
फाइव है।
सही है, सही आ रहा है।
वो उसको इंटू करके फिर रेशियो निकल गया।
हम्म।
There is x5.
एक्स इज 5। हम्म, करेक्ट। व्हाट अबाउट अदर्स। See what you have to do here. Now let me solve it because time is over. Let me solve this. Now, this question we have not done earlier by 7. अच्छा, do it at home. This one I'll tell you quickly for others. See how to solve it because masses are same. Here what concept you have to use, the masses are actually same. Mass of one is rho into pi r square into its thickness. So m1 will be equal to rho 1 into pi r1 square into t1 thickness. m2 will be equal to rho 2 into pi r2 square into thickness t2. Now masses are same, m1 is equal to m2 because it's given, they are of same mass. So you can do rho 1 into pi r1 square into t1 is equal to rho 2 into pi r2 square into t2. Mass into volume I am doing, that's all. So pi will get cancelled and r1 square by r2 square will be equal to rho 2 into t2 divided by rho 1 into t1. Rho 1 by rho 2 is, so it's 5/3. Rho 2 by rho 1 is 5/3 and t2 by t1 is 0.5 by 1, which is 1 by 2. So it's 5/6. That's why your answer is 5. If you are having difficulty in understanding, this is a disk. How to find it? This is having some thickness like this. With the thickness is t. Area of this is pi r square. Its volume will be pi r square into its thickness t, and mass is equal to density by volume. So that's why, sorry, ulta, density is equal to mass by volume. Density is mass by volume, so mass will be equal to your density into volume. So that's why I have done this one. Mass I have found as rho into pi r square into t. Okay, I think you should have understood this one. Do it, the above question, if you have not done, do it as homework.
Yeah,
The
we finished the above question.
huh?
We had done the above question.
If you have done, what was the answer? You did not tell me. No one.
You only told it was fine.
I told. Oh, I forgot what I was thinking.
The
Achha,
next one would be 3.
अच्छा, next one also you have done. Okay. If anyone is not done, you can just solve it at home. The answer she is getting is 3. Hmm. Let me just verify. 3 is the correct answer. Okay, let's end the class then. Good night, everyone.
Bye.
Bye bye.
Bye.
Bye bye.